Hello from Chem Help ASAP. Let's try a slightly more difficult SN1 reaction. If you want, be ready to pause the video if you want to test yourself before I give the answer. Our reaction is on the screen. We have the starting material and reagent, and we need to determine the final product. Go ahead and pause the video if you want to try this on your own. I'll hold for 5 seconds. This reaction does not have a strong nucleophile or a strong base. It cannot be an SN2 or an E2. We don't even have a good leaving group. We do, however, have a strong acid, HCl. The acid can protonate the alcohol to form OH2+ to make a good leaving group. So here is our product of our protonation with our good leaving group. Sometimes you have a solvent with the strong acid. The protonated solvent will do the protonation. In this case, we are not given any solvent on the reaction arrow, so we should use the provided acid. Because we aren't doing an SN2 or E2, the leaving group will leave to make a carbocation as long as the carbocation is a good carbocation. Ideally, it will be tertiary, although secondary can still work. In this case, it will be secondary, workable. The carbon-oxygen bond breaks, and we get a secondary carbocation. Normally we think of a carbocation as having two fates: attack for an SN1 or lose a beta hydrogen for an E1. Since we have a secondary carbocation, another outcome is possible. We could have a carbocation rearrangement, a hydride shift to get a more stable tertiary carbocation. For our current reaction, this will happen. A hydrogen on a beta carbon can hop over with its electrons to give a new, more stable tertiary carbocation. There are other possible beta hydrogens, but these will not form a tertiary carbocation. So we get a hydride shift. Note that not only is a new carbocation tertiary, an improvement over our secondary, but it can also be resonance stabilized by the benzene ring. This is a really stable carbocation. Fine, now we have a stable carbocation. What happens next? Well, carbocations have two fates: attack for an SN1 or lose a beta hydrogen for an E1. If we have any nucleophile at all, even a weak one, we will get an SN1. We do have a weak nucleophile, chloride. Chloride attacks our carbocation, and that gives us our SN1 product. SN1 reactions always involve multiple mechanism steps. At the least, you have two. First, you form the carbocation. Second, you attack the carbocation. All these mechanistic steps are covered by a single reaction step. In this case, just HCl. That's the only reagent, so we do not need to number steps on the reaction arrow.